Algebra Unit 11, Lesson 3, Notes 3, Writing Exponential Functions. An exponential equation is an equation in which the variables occur as exponents. Recall that the general equation for an exponential function is y equals ab to the x, where a represents the initial value at x equals 0, and b represents the common multiplier. Write the exponential equation from each table. Letter A. Now, when we have an initial value, when x equals 0, for instance right there, I know what my a value is. My a value is 1. It's essentially like the y-intercept, okay? The b value is what's happening with the y's. From 1 to 7, 7 to 49, 49 to 343, it's being multiplied by 7. So the b value is 7, which means the equation in the form y equals ab to the x, y equals 1 times 7 to the x. Now when we have a 1 for the a value, we don't have to write it, so it's simply y equals 7 to the x. Okay, this won't always happen where you're given the starting value. So let's take a look at E. When we're not given the starting value, we're actually just going to use our equation, y equals ab to the x, to find our starting value. So pick any point. I'm going to choose the first one. The y value is 3. Plug it in. We don't know a. The b value, well, we can still figure that out. What's the pattern here? 3 times what gives you negative 12? Well, that'd be negative 4. And then negative 12 times negative 4 is positive 48, so that works. So our b value is negative 4, and our x value is 1. 3 equals a. Negative 4 to the first power is still negative 4. To get a by itself, we're going to divide by negative 4, and I get my a value is negative 3/4. So again, using the standard form y equals ab to the x, I'm going to replace the a and the b. Y equals negative 3/4 times our b value to the x. You cannot multiply negative 3/4 and negative 4 because negative 4 is being brought to an exponent, so you would leave it just like that. Let's take a look at one more like this. Let's look at F. Okay, it's important to note that this has n and f of n. Okay, so our final answer has to be n and f of n. Well, our pattern here is divide by 5, but we can't put division. We have to write it as multiplication. Well, divide by 5 is the same as multiply by 1/5. So our b value is 1/5. We're going to pick any x and y values, so I will pick the first one. Y equals ab to the x. Our y value is 100. Don't know a. We found our b value to be 1/5, and our x value is 1. 100 equals a times 1/5 to the first power is just 1/5. To get rid of 1/5, we're going to multiply by 5/1 on both sides, and we get 500 equals a. So our equation, remember again, we have to use f of n and n. So f of n equals ab to the n. F of n equals 500 times 1/5 to the n. Okay, do B, C, and D in this section. Write the exponential equation from each graph. I will do letter B with you because I think it's a little bit more difficult to pick out the points, and then you can do A on your own. Letter B. Well, in order to write an equation from a graph, I'm simply just going to record the table. Okay, so our graph comes in from 0, 100, and then it's at 150, And you could probably guess where 2 is. It's in between 20 and 30. So it's 25. There's already a pattern emerging, so I'm going to stop. I'm dividing by 2, but again, we can't divide by 2, but we can multiply it by 1/2. And that's our B value. In this instance, we are given an initial value, so I know my A value is 100. Y equals AB to the x. Y equals 100 times 1/2 to the x. Go ahead and do A. Okay, on to some word problems. Let's look at letter A. A typical thickness of toilet paper is 0.001 inches. How thick is the stack of toilet paper after 1 fold, 2 fold, or 5 folds? I bet you are always wondering about the thickness of toilet paper. So here we go. When you fold a piece of paper, toilet paper, anything in half, what happens is the thickness doubles. And it continues. Okay? So let's start with the table on the left. And we're going to actually expand this table quite a bit, so don't write very large. Okay. So the thickness of the toilet paper starts at 0.001. When I fold it once, it doubles. So multiply that by 2. So 1 fold would be 0.002 inches. Fold it again, and it doubles in thickness, which becomes 0.004. Keep going, 0.008. I want 5 folds, so I'm going to keep going. 0.016, 0.032. So that's the thickness of the toilet paper after 1, 2, and 5 folds. Now it wants us to write an equation that models the thickness of the folded toilet paper after n folds. So we're using the variable n. We're going to use our equation, y equals AB to the x. We know our starting value. Our starting value is 0.001. We also know the B value, since it doubles each time, B equals 2. So we know y equals 0.001 times 2 to the x. However, it wants us to use n. So f of n equals 0.001 times 2 to the n. So I just rewrote it with n and f of n. Now we have an equation. After how many folds will the stack of toilet paper pass the 1 foot mark? 1 foot, remember, is 12 inches. Well, we're at 0.032 inches. So at this point, I want to go to my calculator, go to the y equals, and plug in this formula. Type in 0.001 times 2 to the x. Plug that in your calculator and look at your table by hitting second graph. And let's copy down the values until we need to hit 1 foot or 12 inches. So 6 is 0.064. 7 is 0.128. 8, 0.256. And again, I'm just getting these from the table in my calculator. 9 is 0.512. 10 is 1.024. 11 is 2.048. 12, 4.096. 13, 8.192, getting closer. 14 is 16.384. So we exceed the foot mark after 14 folds. This next question is a little more involved, has a little more calculations. The moon is about 240,000 miles from Earth. Compare the thickness of the toilet paper folded 50 times to the distance between the Earth and the moon. So now when you go in your calculator, I want you to scroll all the way down to 50 times. You should see scientific notation. So you should see 50 and then next to it 1.1 E12. Remember that means it's in standard or scientific notation. So I want you to highlight. So after you have 50 highlighted, go to the right and highlight that scientific notation. If you look on the bottom, it will expand it for you. Okay, so this equals 1,1,2,5,8,9,9,0,6,8,4,2 inches. What we need to do is we need to convert this number into miles. Okay. Well, we have inches, and I know we can go from feet and then to miles. So inches to feet to miles. So we take this amount of inches, and we can divide by 12 to get the amount of feet. So 1,1,2,5,8,9,9,0,6,8,4,2 divide by 12 equals, that equals 938 2 4 9 9 2 2 2 4. Now in the calculator, let me just go there real quick. If we were to type this in, 1,1,2,5,8,9,9,0,6,8,4,2 divided by 12, we actually get this number times 10 to the 10th, which means we have an extra digit there. Okay. But you can go ahead and leave that amount in your calculator. We then need to take that amount, which is now in feet, and we need to change it to miles. To do that, we're going to divide by 5,280 because there are 5,280 feet in a mile. Oops, I think this is a 4992. Yep. So 4992240 divide by 5,280. Again, just leave it in your calculator and divide. And we get 1,776,988,4.89, and this is in miles. Okay. So if we were to fold a piece of toilet paper 50 times, the thickness would be 17,769,884.89 miles. That is really quite a concept to think about. Now, could you physically fold a piece of toilet paper that much? Probably not. Okay, the toilet paper is only so big. But that's crazy. The distance from the moon to the Earth is 240,000 miles. This far exceeds that. Let's see how much it exceeds it by. I'm going to move over a little bit. So I'm going to take this number, 17,769,884.89. Now I'm going to divide it by the distance from Earth to moon. When you divide that, you get 74.04 and so on. Okay, so that means the thickness of the toilet paper is about 74 times as big as the distance from the Earth to the moon. That's crazy to think about. Let's go ahead and type that up because it wanted us to compare. So again, the thickness, of the toilet paper is about 74 times the distance from the Earth to the moon. And that right there is our answer. Go ahead and try letter B on your own. Okay, we're going to do one more together. Let's look at letter D. Mrs. Davis is making a poster of math formulas for her students. She takes the 8.5 inches by 11 inches paper she printed the formulas on to the photocopy machine and enlarges the image so that the length and width are both 150% of the original. She enlarges the image a total of 3 times before she's satisfied with the size of the paper. Write an equation that models the area of the poster A after n enlargements. Okay, so we are using A for our y and n for our x. So we have to remember that our final answer will be A equals, and then n is our variable. Okay, to do this I'm going to create a table, and I'm going to zoom in quite a bit here. Okay. So to begin with, okay, we're going to put a 0 to start. The length and the width was 8.5 and 11. Actually, we'll call this width and length. We're concerned about the area, so we're also going to find the area. It is a rectangular piece of paper, so 8.5 times 11 is 93.5. Okay. I'm just going to, she wanted to enlarge it 3 times. She enlarges each dimension by 150%, which as a decimal is 1.5. So I want you to take, let's start with the width of 8.5. 8.5 times 1.5 is 12.75. And I want you to keep multiplying by 1.5. So this is 19.125. And one more time, times 1.5, 28.6875. Okay. Do the same with 11. 11 times 1.5 is 16.5. Times 1.5 is 24.75. And times 1.5 is 37.125. And now find the area by multiplying the dimensions together. We have 210.375. Multiplying these two together, we get 473.34375. And again, we get 1065.023438. Okay. So we are concerned with our x values, which actually are n values, so let me change that, and our area, which is A. We want an equation. Well, we know the starting value is 93.5. So I know that A is 93.5. To find the B, I have to figure out what's being multiplied. Well, off the top of my head, I cannot tell you what 93.5 times what gives me 210.375. So do the reverse. Do 210.375 divided by 93.5. And you get 2.25. So the B value is 2.25. So my formula y equals ab to the x. Remember, we're using a here. A equals 93.5 times 2.25 to the n. So there's our formula. What is the area of the final image compared to the area of the original, expressed as a percent increase, rounded to the nearest percent? Percent increase, the formula is change over original equals percent over 100. The change is the subtraction, is the range, essentially, from between the two values you're concerned with. Well, she enlarged it to 1,065.02348 minus the original area of 93.5. And again, that's the original, so that's our denominator, equals x over 100%. Cross multiply. Oh, before we cross multiply, we need to actually do the subtraction. When we do the subtraction, we get 971.523438. Rewrite everything else. Now let's cross multiply. 93.5x equals 97152.3438. To solve, we're going to divide by 93.5. And we get 1039.062501. Wants us to round to the nearest percent. So 1,039% increase. Okay, do letter C on your own.